No.
Review, going over the review. I've already filled out some of the differences because that's the part that kind of takes a little bit longer as I'm like walking and talking through it, okay? So starting off with number 1, but on the review, this is actually number 5 or something weird, okay? Differences. On the table, what do you notice about the table that's a little weird that they gave us? Or didn't give us?
The 0.
A sub 0, they did not give us the A sub 0, so we gotta go backwards. But first we gotta do the differences. 11, 15, 19, and 23 is the first layer here, and I move on to the second layer. It's going by 4. Okay, cool. Going back to find A sub 0 though, I go back by 4 because I know this is going by 4. 11 minus 4 is 7. So 11 goes back by 7. 11 minus 7 is 4. It all works.
Aha.
Okay. Now for the equation, I have A, right? I'm not going to write the second layer difference, the first difference, and A sub 0 every single time. You should be able to look and identify the second layer difference, the first difference between 0 and 1, and A sub 0. Okay, so A comes from getting
The second difference.
second difference and doing what to the second difference?
You divide by 2.
Divided by 2. You will have all the formulas on the test. So A is 2. Got it?
Wait.
You will have all the formulas on the test. I forgot to tell you that. Test this week. B, I got 7, the first difference. 7 minus A is 2, and we're good. Biggest mistake I see for B is doing the first difference minus the second difference. And instead of, nope, it's minus A, so be careful with that. Minus A. So B is 7, 5. Cool. And then C, I'm going to write it over here. C is just A sub 0, so we got 4, and we're done. Cool. All right. Now, so that equation, y equals A x squared. So we got 2x squared plus 5x, because B is 5, plus 4. There we go. Marker's dying on me. Okay. There you go.
Rest in peace.
Next one, number 6, okay? Whenever you start doing all the layer differences, what do you notice as far as after you do the first layer?
The x is bad. Oh, it's all 3.
It's all the same number, so that means this is a linear. Okay, that's important to know. Second layer makes it quadratic. Here's what most people did. So I have, if you remember, it's y equals dx plus a sub 0. This marker's also dying on me. What is the d value?
The difference.
The difference, right? So y equals
3. -3.
-3. I'm writing it right there. X and then plus a sub 0. A sub 0 is 12. Okay? But that's wrong.
Because the x,
Look at the x values. What do you notice over here, though?
They're different.
They're going by 2s, okay? Again, this would be correct if it was going by 1s. We remember on last test, there was a curveball, right? If you remember I'll write it right here. The change in y over the change in x is your difference, right? The slope, okay? So the change in y, we already found that. That's -3, but what's over the change in x? So I'm gonna put over 2. That's your correct answer. Careful with that. Careful with that, okay? Moving on, number 8 on your paper. Number 8 on your paper. If you notice on number 8 on your paper, you do the first layer difference, it doesn't work. Do the second layer difference, it doesn't work. You go to the third layer difference, and it doesn't work. It's not an average even situation. It's just neither, okay? We will talk about the average here in a second. The only time I want you to do the average thing, though, that is correct and that is good that you're looking out for that, is if they specifically ask you, hey, what's the average, or estimate, or approximate, or whatever, okay? Moving on to number 10 now. We got this table. What's the weird thing about this table? It's very good to identify these types of things.
It has a negative in the x.
Oh, it starts with a negative in the x, right?
Yeah.
So my 0 is not at the top, so be careful with that, okay? At least we don't have to go extend the table to find it. I do my first layer differences. Make sure you catch that they're negative. That's another big thing. People just like to put positive numbers here and not think about negatives. Watch your negatives. And then I am going down by 2, I'm going down by 2, and I'm going down by 2, okay? So, my A value is the second layer difference divided by 2. A is -1. Careful, it's a negative 1. Negative 1. Careful, and you'll see why in a second. B value. What's the first difference? What's the first difference?
No, that's not right.
I like the head shake in the back. Yep, we're like,
No, it's the first difference
nice
is
try.
right, 0.
10, yes, very nice. Negative 10. Between 0 and 1, this is my first difference. Very nice. So I got very good at catching that. Negative 10 is my first difference.
Nice.
And I'm going to minus A. Whew, I'm nervous. I'm going to minus A.
Minus negative.
But A is negative, so I'm going to minus a minus.
Add it.
So add it. Very nice. So I'm going to say plus 1. Okay. Instead of minusing a minus 1, I'm going to plus 1. Same thing. Okay. Cool. So now B is negative 9. Negative 10 plus 1.
Good job.
C, don't get tripped up. C is 0. It's right
5.
there. Or sorry. At 0, C is 5. Cool. There it is. ABC. We got y equals negative x squared, because negative 1, minus 9x.
Plus 5.
There we go. Cool, cool, cool. All right, moving on to the next page. We got a bunch of little dots all over the place, okay? And it's asking us to find a table, extend the value, all this kind of stuff. What's the relationship? Relationship's the same thing as an equation, same thing as finding a function rule, or all these other rules that mean the same thing. All right, so got it. Here's the little table. Oh, dang it, don't look. People at home, don't rewind the video to see what that answer was just now, okay? We're watching.
We know.
YouTube lets me know if you rewind. I'm just kidding. It doesn't. Okay. So I'm going to do the table, all right? So I'm going to extend this out. All right, what's my pattern? A 5, 9, 13. It's going by 4s. Cool. I can't get a function rule. I can't get an equation for it until I get my 0. So I'm going to go back to get my 0. Back by 4 because my pattern is 4. 5 minus 4 is 1. Back to the original table. 1 minus 1, 0. Yes. Okay. So now I can do my function rule. Now here we go. I'm going to see if you guys can hang with me on this. I'm going to do a next level turbo speed run hack.
I know.
I'm going to speed run this problem.
I'll do it.
All right. Look at me using cool hip language.
Uh-huh.
All right. Anyway, so I got y equals. Okay. It's going to be ax squared plus bx plus c. I already know how to find ABC. I'm just going to write them in there and do it all at the same time. So a is half of the second difference. So it's a is. Oh, it's too fast. Speedrun's too
Sorry,
fast.
my brain lied.
Ax squared, this is a, I'm looking at here. I am dividing that by 2. So I have 2x squared, because that is your a value divided by 2.
Yeah.
Second layer difference divided by 2. I'm just going right into it. See what I'm saying?
Yeah.
All right. B is the first difference minus a. So I'm going to do the first difference.
I just won.
Minus a is negative 1. So I'm going to put negative 1x, but then that's cute, so I'm going to erase the 1, and it's just negative x. So it's just minus an x. Oh, God. And then plus c.
0.
It's not there.
Done.
Yeah.
Cool. All right. There's my equation. In this case, it's the relationship or whatever. Cool. Got it. Now, it asked us to find the fifth one, to find 5, okay? Do you want to do it the extra way or the basic way? Basic? Okay, cool. Basic is pretty easy. I'm just going to extend this one more time. Because 5's right there. We got 4. We just need this one. So it's going by 4.
17.
13 plus 4 is 17. 28 plus 17 is 45. Bingo.
Yay.
There's the basic way. But if you don't want to be basic, you can plug in 5. You can plug in anything and it works, right? So I'm going to do it in a different color because I can. So I'm going to have y equals 2 times, this is going to be 5 squared minus 5. I'm plugging in 5 for x, okay? 5 squared, I got 2 times 5 squared is 25. You with me on this so far? Okay.
Wait.
Again, I would not put all of this in the calculator all at once. That makes me nervous. Anytime y'all do that and you'll just start typing massive long equations in there, I start sweating. 5 squared, sure. If you know it's 5 squared, then just do 2 times 25, whatever you want to do. Do each individual calculation in the calculator. That is my tip to you. All right, so 5 squared is 25. 2 times 25 is 50. 50 minus 5.
45.
Oh, we got 45. Okay,
Wow, magic.
So magic. Okay.
And what
You
about
can call me a mathematician. Mathematician, but all right, anyway. So it's funnier if you're here. Like they all laughed, but I edited out the laughing. So don't laugh now because it looks like I didn't edit. Okay. Anyway,
what about 13?
This brings us to the next problem though, because it asks us, what if we have 9? Like, what if there was 9? The figure, plug in 9 for x basically. So I'm gonna do the same thing, but I'm plugging in a 9 instead. Okay. So I have 2 times 81, because I squared the 9. That's 161 minus 9. So or 162. 162 minus 9, so I have 153 is the answer for 9. Can you see the green marker on the screen? I guess maybe you kind of can. Last one. So there's some room here. On the back side, this is where it's asking you to estimate, approximate for a quadratic equation, all that stuff. Okay, guesstimate. All right, we got the first layer differences here. Oh, erase that. All right, I'm gonna keep on going. Give me the differences here, though. I don't know these ones. Negative 15 to negative 47.
Negative 15 to
negative 30 what? 2. Negative 32, and keep it going. Negative 30. 36? Okay.
Maybe.
Negative 30? This was negative 29. And then 5, 7, negative 37? Okay. Okay. So, it's not a perfect quadratic. That's okay though, because what are we going to do to it? Average. I'm going to average all this together. Okay. We've done a whole unit 2-4 was over this, or 2-5 was over this. The last video. Link right here, although I probably won't put the link right there. Just go find it on the channel. Anyway, so the average here is 32.8 is the average of all these numbers, okay? Now I'm going to do the same dang thing with A, B, and C that I've been doing this whole time. No, only difference is that I just had a little curveball of an average. Everything else is the same. So I have A equals 32.8 divided by 2. It's the second layer difference divided by 2. Oh, this is wrong. Good catch. That was a test, and you were the only one that succeeded.
You didn't even know.
I'm just kidding. All these are negative going down. All these are negative going down. This was also, make sure you don't lose the negative. Yes, good catch. So then that means this is negative, which means A is negative 16.4. Cool. Yeah. All right. The B value, I'll do right here. The B value is negative 15, because it's the first difference. Negative 15. Minus A, which means plus. I like you just said plus right there. 16.4. So then B is 1.4.
Wow.
Okay. And C, good old C, is your 800 A sub 0. A sub 0. A sib. All right.
What's going on?
Okay. Y equals negative 16.4 x squared. There's your A. Plus 1.4 x plus 800. All right. Okay. For the last question of this whole thing, it asks you about when would the time be for when the thing hits the ground. Okay. This thing's 800 feet in the air. It keeps dropping and dropping and falling and falling and falling and faster, faster, faster. About when would it be? Thoughts? Oh, so I'm going to look at this and I'm going to estimate where everything's going on here, okay? For myself, if I'm estimating when it's going to hit 0, we're really close to 0. And this is just pure estimation skills. It has nothing to do, I mean, I guess estimation's math, but that's just kind of logic more so than like calculating anything. You're going up by 30 something every time, or I guess going down by 30 something, each of these numbers, right? So I'm going 140 something, 170 something. What's the next one going to be? Like what? Like 200 something, right? So I'm going like 200 something. Again, I'm estimating. See, I'm not doing super perfect calculations right now. I'm just estimating. I'm going like 200 in 1 second. I'm going to go 200 more down. So where's this going to be? really close, right? I'm gonna be like about 10 or so. The answer is 9 if you extend the table. If I extend the table by negative 30, whatever, this is going to around 9. So I'm gonna put an approximately sign right there. So at 7 seconds, you're at 9 feet above the ground. Okay, so if you had to give me a super close estimate of when it would hit the ground, what would you say, something point something? 7.7? 7.5? For the sake of this test, you'd be correct, and that's close enough. You get the idea. It's between 7 and 8. That's correct. But there's a Unit 8 test coming up, and I want to try and be super, super specific for. I would say 7.5 would be way off.
Huh.
I'm being hard on you right now. What do you think it would be? 7 point what?
9.
7.9. Ooh, all right. So hold up. At 7 seconds even, we are 9 feet above the ground. How fast are we going here?
Negative.
Very fast. We're coming in hot, right? Like you are falling 200 feet per second, and we're 9 feet above. We're like the ceiling right here, coming in 200 feet per second, and we're about to smash into the ground. At 8 seconds, you're going to be like negative 200 and something feet into the ground. See what I'm saying?
Oh, sweet.
So 7.9. Whoo! We're burrowed.
We killed the
right?
dinosaurs.
We're down there. Okay. Probably the ground would slow you down and whatever. But what would you say the height would be? So that's right on. I'd say 7.1. And the reason why I say 7.1 and why I'm being a stickler about that is we're at 9 feet, literally right after 7 seconds. We're hitting. Okay, so I know that's like I'm being super extra about the whole thing, but that is very accurate to where I want y'all to realize that we're really close right now. You could almost say 7 and you'd be accurate, right? Because we're coming in so fast. Okay, but 7.1, 7.01, 7.05. I don't know. Accuracy. Okay. Boom. That's it.